All right, so if you look at this problem, do any of the numbers, the P's or the Q's, do they have the same numbers out front? Any of the letters have the same numbers out front already? Nope. All right. Now, I do notice something, that the Q's have a plus sign and a minus sign in front of them. That's kind of nice because they've got the opposites, and I know I need opposites. And there's something else nice about the Q's. What's nice about the Q's? Yeah, I could multiply that bottom equation by 4, and it would match the top one. It would have, because 4 times 2 is 8. So I could have made a different decision here, but this is going to be the fastest way to work the problem. Had I chosen to get rid of the p's here, for instance, I would have had to multiply the top one by 5 and the bottom one by 3, equation by 3, and I want to make one of those negatives just so they cancel out. But I can do that faster here because I'd rather just mess with one equation if at all possible, right? All right, so what does that turn out to be? Well, 3p, we still have the top one is exactly the same. Okay, but the bottom one, if I multiply everything by 4, and I'll write it in green just to show that it's a new equation, what's 4 times 5p? 20p, okay? Remember, I got to multiply by everything. What is 4 times negative 2 in front of that q? 4 times negative 2 is negative 8, and then I stick the q there. And then 4 times 21, don't forget him, 84, okay? All right. What's going to happen now with the q's? When I add these equations together, what's going to go away? Because if nothing goes away, there's no point in me adding the equations. What's going to happen when I add the two equations? Yeah, this 8 plus 8q minus 8q is going to add it to 0. We say they cancel out is another way of saying it, right? Okay, so yay, I've got it set up now. I can proceed, and I know I'm going to get somewhere with this. 3p plus 20p, if I add the equations now, is, 23p. Thank you. And then 8 plus 84, I believe that's 92. Okay. And I want to figure out what p is, so I want to solve for p. And I can do that by saying, since p is multiplied by 23, the opposite of multiplying by 23 is dividing by 23. If I circle that p, my eye goes back to that side of the equation and reminds me that's where I'm supposed to be working. I don't want to move the 92. I want to get rid of the 23 because I want p by itself. And I believe that's 4, isn't it?
Yes.
Yay, we love these whole numbers because we got to plug them in. We don't want to plug in a fraction. P is 4 when you divide that out. Okay, so remember, one of the things we said we were going to try to do is keep up with our answers as we go, so we make sure we got everything in the right spot. We got P's and Q's, and in the alphabet, P's come before Q's. So I'm just going to write that in a little bitty up at the top just to remind me where I should put this 4. Is it going to go in the first position or the second position? P's go first or second, guys? First. Okay, so I'll put the 4 there. Now I got to find the Q. Having that empty reminds me I need to find Q. And I'm going to plug in P equal 4. So what do y'all like? Top equation, first one or second one? If you don't like negatives, maybe you pick the first one, you think? Okay, that's what I like. I don't like the negatives if I don't have to have them. 3P plus 8Q is 8. Oh, I know what P is. That's what I can plug in. Okay. P was 4. Put it in there. What is 3 times 4? 12. 12 plus 8y is equal to 8. Oh, I thought I was going to get away from negatives, but I'm not, am I? Because if I want to get y by itself, the first thing I do is add or subtract anything, because that's PEMDAS backwards. Oh, did I write something wrong? I wrote a G or something instead of a Q. That should be a Q, thanks. Let me make it go out. That's a Q there. Thank you. To get Q, I can subtract 12 from both sides first, right? And that would be 8Q equal 8 minus 12. What's 8 minus 12? Yep, thank you, Kaylee, negative 4. And if I want to get Q by itself, it is multiplied by 8. The opposite of multiplying Q by 8 is dividing it by 8, and that would make the 8 over 8 become a 1Q, which is just a Q. Oh, we got a fraction, but we don't care because I don't have to plug this in anywhere, do I? Yep, it reduces. You want to reduce it to negative 1/2. Do not write negative 4/8. We always in algebra reduce our fractions because if we did have to plug it in, it would be easier to plug in negative 1/2, and it's just polite to reduce your fraction. Brain doesn't want to see the decimals. What can I do in these problems to get rid of the decimals? Yes, I can move all the decimals over one spot. That's the same thing as multiplying by 10. So I'm actually going to show that up here. Now, what I do, I know I could do 2 or 3 things at a time if I wanted to, but I'm going to kind of make sure I don't mess up by doing a little bit at a time. If I basically bump all those decimals over on the first one, that would become 3x plus 5y, and then 31 times 10 would be 310. Okay, so that number is going to be bigger, but at least we don't have to look at decimals. And the bottom one, I'll make it green. If I bump it all over 1 on that, which is the same thing as multiplying by 10, that would be, what, 2x. What would come next? Minus 1y. Let me go ahead and write the 1. I don't have to, but I will, just because I can. And then instead of negative 1, it will be a negative 10. Negative 10. All right. Can I solve this just right off the bat? If I add stuff together, is anything going to cancel out? No point in adding it together if nothing cancels out. And I don't see any of the x's or y's with the same numbers out front. What do you think we would want to get rid of here? What would be the least amount of work? Yeah, if you get rid of the y's, that would help. A couple of reasons. One reason is there's a plus and a minus in front of my y term, so that kind of sets it up where I've already got an opposite going on. But then this, anytime I find one of these 1 y's or 1 x's where there's just one of something, isn't that easy to make it match the number in front of it just by multiplying? Since there's a 5y, couldn't I just multiply this one by 5? Wouldn't that get me a 5y, a minus 5y actually? So if I recopy my first equation, I'm not going to change it. Oh, well, I did change it. It was a decimal, but at least I'm not going to change it anymore. And then 5 times, I got to distribute. 5 times 2x is 10x. 5 times minus 1y is a minus 5y. That's why we picked 5, because we wanted that to happen. We wanted those to cancel out. And 5 times negative 10 is negative 50, okay? So the reason that helped, what's going to add up to 0 here? The y's. 5 plus 5y and minus 5y add up to 0. They go away. Yay. We like that. As a matter of fact, we couldn't go anywhere if that didn't happen. That's why we had to get it to happen. Again, did I have to pick the y's? No. I could have, if I wanted to get rid of the x's, I could have multiplied the top equation by 2 to get a 6x. And then maybe on the bottom equation, to get a 6 out in front of the x, I could have multiplied it through by 3 and maybe a negative 3, and that way I would have created opposites. So there's more than one way to do this. We just like working smart, don't we? We don't want to have to do more work than we have to. All right, so because I can add these and they cancel out, let me just add everything up. What's 3x and 10x? 13x. And then the y's cancel out. I could put plus 0, but just I won't. 310 plus negative 50, that's the same thing as 310 minus 50. What would that be? 260. Thank you, Luke. 260. And again, you could use your calculator here if you don't want to do that in your head. And I want to get x by itself, but it is multiplied by 13. So to get rid of the 13, I will do what to it? Am I going to subtract it? No, divide it, because it's glued with multiplication. The opposite of multiplying is dividing. So those cancel out, and oh, look at that, it goes in nice and evenly. X is 20. Let me put my answer up here. I'm going to make a box or a circle or a bubble for my answer. And these are x's and y's, and that's kind of nice because we're kind of used to x's and y's and points anyway. So the x is 20, it goes in the first spot. If I put it in the second spot, I'm telling you that you're telling me that y is 20 instead of x is 20. And so we don't want it there. Oh, I can tell by looking there that I need to find x, and to find it, I'm going to plug in what I already know into the equation. I got to plug in x equal 20. All right, I don't want to go back to one of those original decimals. That's just gross, right? So I can pick one of my new equations that I scooted stuff over with if I wanted to. Y'all want 3x plus 5y is 310, or do you want the one below it? The one below it? Okay, we can do that. It doesn't really matter. I'm going to pick purple. I'm going to circle. So just because somebody said below, I'm going to pick this one. That's the only reason. I could have also picked the top one. So I have 2x minus 1y, which is just minus y, equal to negative 10. but I know what x is. It is 20, so I'm going to plug that in. Okay, so I plug it in. 2 times 20 is 40. 40 minus y is negative 10. Okay, I can subtract 40 from both sides, right? I would have negative y, if I add, if I'm solving negative y, and then negative 10 plus negative 40 is negative 50. Negative y is negative 50. Do I want to know what negative y is, or do I want to know what y is? Just y. So I could, to get rid of that negative, I could just switch the signs on both sides. I could divide both sides by negative 1. I could multiply both sides by negative 1. I'll just write in divide both sides by negative 1. All that does is switch the signs, though, because a negative 50 divided by negative 1, which you can't really see on the iPad screen, negative 50 divided by negative 1 becomes a positive 50, and that's what I'm going to put over here in my answer blank. So even though you have x equal 20 down here and y equal 50, write it up here and circle, bubble, or box in your answer so you can find it.